So one of them is that you're going to have these zones which allow you to view information about a project. The palette will give you items that you can add to that project to build it up, to customize it to your needs. And over here in the properties area, you're going to be able to get information about selected items. So let's go, rather than talking about that at the abstract, let's build our first model. So go to File, and then do New here. And this will allow us, it'll give us a little wizard here, so-called wizard, little dialog box that will let us build our first model. And it's looking for a bit of information on us. And I'd like you to put in a title here that will be a little bit evocative. It will be Simple Gender Disparities in Income, okay? Or you could say, to make it a bit briefer, simple gender income disparities, okay? We're going to use this to kind of build up a simple model which exhibits heterogeneity, which is one of those features that recommends agent-based modeling, the capacity to represent heterogeneity in a population in a scalable way, that as you take into account more and more heterogeneity is scalable in a flexible way, and in a way that allows for both continuous and discrete types of heterogeneity. So I've typed in simple gender income disparities, and you can choose here the model time units, and we're going to choose, ladies and gentlemen, years here. We're actually not going to do anything too fancy with dynamics in this model. We're going to rather look at it to just have some elements of heterogeneity. Okay? And let's do finish. So the model will have a natural time unit of years, but we're going to be able to specify values in the model, like how quickly someone recovers from a bug in whatever unit we want. We just will be explicit, saying this is in, you know, an average time of 1 week with the flu or what have you. So we do have a default time unit. If we don't associate any specific time with things, it'll be interpreted in years. Okay, so having done that, what you will see is over here in projects, you should see something like this. Do you see that? So I pressed OK, and you see a projects window over here. You have main and you have simulation. Does anyone remember from yesterday, what do those kind of symbols mean? You'll see these kind of symbols. One is Da Vinci and main, the measure of man. And then the other is for this X, for a simulation. So what is that thing called simulation? I called it yesterday a what? A experiment. I also called it informally a scenario. It will let us run this model with different assumptions about the particulars of the model. They'll all run with the same model structure. The same model structure is captured by things like Statecharts or stocks and flows and parameters and variables. But the particulars of what we assume will be different. We can change parameter values specifically. And then main is going to be, as I said, the stage in which agents strut, or the place in which we'll put stocks and flows for system dynamics modeling. Things that apply across the entire model will be captured in main. Okay? So this little panel allows us to explore hierarchically a model into various pieces. Okay? Now, selecting any one piece here or over in, it turns out in this canvas, we could see properties on it over here to the right. So this properties window. And very importantly, ladies and gentlemen, you'll find that, and this is something to really make note of for those new in AnyLogic. Typically in the properties, often in the properties window, the properties for a given object will have these sections which have these little triangles there. What do these mean? The fact that there's a triangle there, what's the implication of that? Yes, collapsible, it's expandable. Now, this is not to be minimized. The fact that it is collapsible is significant because sometimes you've modified things in there and you want to be sure that it's visible. So just be aware if you're looking for something, sometimes you want to expand these things so that you can find if the thing for which you're searching is in there. And we're going to be doing a certain amount of modification there that will require expanding some of these things. Okay. Okay. So that's good. Yesterday we frobbed some of these settings up here for experiments to get it to show the model time, or to get it to let us navigate the model, or to pan in the model to move around. And in general with the properties window, that's how you'll set sort of the characteristics of things in your model. Okay. Now the other component though is this palette, and that we're going to use this palette to put things on what I term the canvas. We're going to use it to add pieces to our model. So, ladies and gentlemen, I would like to add some pieces to this model. But first, what I'm going to do is to add something not, we'll add it through the palette. Sure, we might as well do it that way. So I'd like you to go over to this particular palette that's shown with a Da Vincian logo, and it says Agent. And you'll notice that there's a thing called Agent here. And this is this provides us with a way of adding agents to our model. But first, I'm going to show you a different way to add in an agent type here. So you can add things here through the palette often, or you can add some things through this menu. And I'd like you to do File, New, Agent Type, and we're going to add an agent type called Person. Now, what is this agent type? Well, ladies and gentlemen, we're describing sort of a category of things. There's going to be we're going to be describing personhood. We're going to call it person. Let's describe personhood. Sort of the theory of personhood with respect to this model. What does it mean to be a person in this model? That's what we're going to enter person here, and that's what this class will define. This type will define what it means to be a person. How did I do that? I went File, New, and then I did Agent Type here, okay? And I typed in Person, okay? And I'm not going to do this template. You can use templates, and it will fill in some extra information for you, and that's all good. But I'd like you to understand from the ground up how these things built. So rather than having it throw in lots of things for you automatically, I'd like you to see how you can do it yourselves, and then you might want to avail yourself of that once you understand what all those pieces mean. Okay, so I typed in person, and then I say finish. Okay, does anyone need help? Annie stands ready. Okay, deployment in Sector 3. Okay, other people need help? Okay, great. Yes, deployment in Sector 1. Okay. So you go File, New. Oh, that's interesting. Okay, so what you need to do is you need to go to Projects. So if anyone does not have, okay, this is great. And what you could do is select that project there and then do New, and oh, that's interesting. Okay, that's an interesting thing. Well, that might not be a bad thing. Let's okay, so that can work to drag things in. Okay, yeah, we can close this. Sure, let's try to close this. Okay, and let's do this. New, come on, new project, new model rather. And can you type that name again? Something similar. Yeah, that's good. And just do years. Yeah, and finish. And then you can go up there after that and do File, New. File, New. Yeah, and model. Yeah, restart edit logic. That's funky. Yeah. Oh, great. Okay, it looks like he's helping folks out. Okay. Okay, is anyone having issues that you'd like TA help for here? Okay. One of the gentlemen here had an issue with it actually not having the option of adding an agent type, and it's I've actually never seen that before, but he's closing any logic and reopening it, and it. That's what we did, but it didn't work. Yeah, you and I think alike, but yeah, I agree with that. It sometimes has these transient hiccups. Okay, okay. So we added a person. You notice that it appears here. Okay, this is describing personhood, and we're going to elaborate this to what our theory of personhood is with respect to this model. Again, models, ladies and gentlemen, I tried to emphasize earlier, There are some models that aspire to be really rich descriptions of the external world. And there are some models that aspire more to serve as learning tools at a very simple level to help us think through, if we had a few very, very simple assumptions about how things were, what would be the implication? And the model we saw yesterday was like that. It wasn't depicting, the spread of syphilis in LA or San Francisco, or it wasn't depicting how TB spreads in northern Saskatchewan. What it was describing was a very simple sort of view of the world in a very stylized fashion and seeing the implications. So here we added person, and we're going to elaborate it to have a very simple set of opportunities. So, ladies and gentlemen, what I'd like to do is to take this person here, and if you double click on it, I'd like you to add to them a representation. So I'd like you to add in, give them one characteristic that we'll start with, which is a depiction. So we'll give them a face upon the world. So if you double click here on person will open up in the canvas. So a given canvas will relate to some piece of the model. One of these components over here, particularly the agent classes, is what we modify most of the time. So if you double click on that, you'll have a canvas here for that component of the model. So now you should see person up here, and it's very important, mark my words, for those new to AnyLogic, it's very important to reflexively check what canvas you're looking at right now. Because one of the easiest mistakes you can make with AnyLogic is you drag something on the model and you're really excited, you've added this mechanism, you've got to run it, and either it doesn't run or it runs and you see something weird. And you say, what's gone on? And what's gone on is that you've added it to the wrong piece of the model. You meant to have agents have a state chart that keeps track of their status, and instead you've added it to main. And somehow it's saying the whole world is infected with chlamydia. And that's not what you want, either in reality or in the model. So, so here you want to be very clear into what component you're adding pieces. Okay, so I double-clicked on this, and here's person. So, ladies and gentlemen, let's go to the palette, and we're going to need to. There's different palettes for different components. We went to the agent palette here to add things. Now,
I'm all set.
You're all set? Okay, great. Delighted to hear it. It was just a matter of restarting it. And
yes.
Yeah, okay. So I'd like you to go to this one just below the agent. There's this one that seems to have various Pythagorean ideal solids or shapes. And I'd like you to go to that, okay? So just underneath this is the shape. And I'd like you to add a particular stylized representation. AnyLogic is filled with all sorts of fascinating clip art, but we're going to keep our representation simple. I'm just adding an oval in. It'll be, in fact, a circle, and I'm going to drag it up here to this particular point. This point is of significance because it's going to be the reference point, the origin for a person. And if we put something on it, what it means is visually they'll appear at their logical position, rather than if we had it down here, they would appear underneath their logical position by some distance. So they're going to be associated, each person will be able to be associated with a certain logical position, and this, by putting it on the origin, it makes sure that their appearance is at the same point they're logically at, which is most of the time what you want. Okay, so I just dragged in, I dragged in from here, from the oval to person. People following that? Who needs help? Okay, help? Okay, okay, yep, you're, okay, sorry? Yeah, that's, Annie looks like she's freed up, so I think those are two people right there, right the row behind you. Could you raise your hand again, needing help? Needing help? Who needs help? Okay, thank you. Great, okay, so ladies and gentlemen, I'd like you to drag this so it's smaller and reposition at the origin, just so we don't have an overwhelmingly large sort of component for someone. Okay, that's great. Okay, okay. Someone in the yeah.
What is the origin of that?
Okay, so again, the origin here. If you locate something at the origin, This is going to be the origin relative to that person, okay? So in general, agents in any logic, in this case persons, can be logically situated at certain points. So they can be located at a GIS location, or they can be located at a certain kind of X and Y location within some grid. Maybe it represents a city or what have you, okay? And the fact that you've located visually this is the origin just means that their visual appearance will be at a location on the, with respect to sort of what's shown on the screen, that's exactly the same as their logical position, okay? So they have a logical position, and if you made this offset by a certain amount, they would appear visually on the screen. It would just be, by looking at where they are on the screen, you wouldn't be able to see, oh, who is that in the underlying population, because it would be offset from it. So basically this gives sort of an indication of the mapping between the sort of relationship between their logical position and their visual position. If it's right on here, the origin, it's the same. Is that? Yeah, okay. Great question. For the most part, it wouldn't matter. For these examples, it will be immaterial. But to help lower risks of misunderstanding later and inconsistencies, it's not to be treated lightly. If you had two different types of agents and one of them was located offset and the other was not, then you'd start to get weird effects where these two are at different logical locations, but they're appearing overlapped and stuff like that. You don't want that. So it's good to just, as a routine habit, put things at the origin unless you need them otherwise. Okay? We will later in this 3 days be locating people elsewhere. Okay, other questions. I love the questions. Other questions? So right now we're building an agent-based model. Okay? Other questions? We're going to be doing each type of modeling in the course of this 3 days, but this is agent-based. Okay? Others? Questions? Okay, so ladies and gentlemen, having done that, I would like you now to make one final step. We've described a theory of personhood. This theory of personhood is particularly impoverished right now. It's particularly simplistic and stylized. All it involves is that a person is associated with a little circle. That depicts them depicts them. Okay, so what we need to do is, this describes personhood, theory of personhood, but it hasn't actually introduced a population of people. So let's go do that, okay? So I do it in my favorite way. There's other ways to do this. But here, what I'd like you to do is open main. So here we have main, okay? So we're going down main, and by double-clicking on this, and up comes main. I pay attention to that because I want a population to live in Maine. Maine is the stage in which agents strut. That's where populations will often live. Not always. You can have a hierarchical model where they live elsewhere. You can have an agent population within another agent. But for now, we're going to have this population of people living in Maine. And I just dragged in from person to Maine, and then I'll actually type population. Okay? How did I do that? Let me rehearse it again, okay, for those not following. So I double-clicked on Maine, up comes Maine, okay? And I'm going to drag in. I click on this and drag, and I let go, and I'm going to type population. Oh, it changed it before I could. Well, okay, fine. I'll go over here, and I'm going to change it over here on the in the properties page. Okay, so I'd like you to drag that in, and then I'd like you to change it to population here. So I'd like you to change this to population. Oops, population. Okay, just like that. Okay, this is going to be a population of agents. We have a theory of agent, and now we're going to have not just one agent, but many agents running around. Well, they're not going to be running yet, but they're going to be sitting around. Okay? Yes?
I just want to know, is there any reason that for the population we started with a small letter and for the agent person we started with this?
Very good question. There is indeed a reason. There is indeed a reason. And unfortunately, that's something I can get to in boot camps often, but it's not something in a 3-day event I would cover normally. But there's a set of best practices that are really admirable to follow and will really lower your risks in modeling and enhance, lower your vulnerabilities to chance. It's basically about not leaving anything to chance. It's about being careful, systematic, and meticulous in how you do things in terms of adhering to certain conventions in some cases, certain practices, and other certain processes, things like peer review and testing, that will help you do more robust modeling. And one of these is to name things carefully. Naming is not something to be taken lightly. When you name things, it's a primary vehicle for communicating with yourself in the future and with others who look at the model what this represents. And it turns out that there's a naming convention which is standard in the technology that underlies any logic, to wit, Java, whereby these things that kind of describe whole groups of things, types of things, classes we call them, that describe theory of personhood, or a whole type of type of carhood. Those things we give in capitals, okay? And then things that are sort of particulars, referring to particular ones of these or collections of these, we'll use in lowercase, and it helps us visually. Someone coming to this model. So, if I were to go share this with people anywhere in the world who apply these techniques, they can look at this and they can kind of parse out, okay, this is a class, this is kind of describes a whole set of things, a thinghood, what it means to be a person, whereas this is some particular set of people or something like that. But also naming it, you notice when I dragged it in, it said person, and this is going to be a population. Calling it person, would it still work? Yeah. Any logic wouldn't complain. It would be perfectly fine, but it would be confusing as all get out. It would be needlessly confusing. It would leave yourself open to danger that someone could misunderstand it. And we don't want to fall prey to that. Is that helpful? Okay. Okay, so, but we haven't finished the job yet. We call this population, but we need to actually say it's a population of agents. Notice when I click on this, over here in properties, I have a choice between single agent or population of agents. And I'm going to say it as 100 agents right now. Okay? Now we're going to be changing this in just a minute, but we're going to leave it as 100 agents. Okay, ladies and gentlemen, what I'd like you to do now is you are now the proud owner, the proud creator, not just owner, proud owner, a proud creator of a model. And I would like you, ladies and gentlemen, to run that model. But those who were here yesterday should be able to tell me how to go run this model. How would I run this model? Okay, yeah, so there's actually several ways. So the way that I prefer, because of specificity, because it's fairly unambiguous to what you're running, right-click, or on Mac, control-click, thank you, and go down and select run. That makes it very clear which experiment I'm running, okay? So how did I do that? I went over to this projects area. I'm not in the palette anymore. I'm in projects. Oh, look at that. Okay, we'll come back to that. And I'm going to right-click on it and select run. And when I select run, up will come a little introductory screen. This is the so-called experiment screen. And this would allow me to change assumptions and maybe fill in some information, but I'm just going to say run now. We're running this model. This model is running. Now, there's nothing particularly interesting going on, but time is advancing. Time is ticking. In what units is this time represented? So it says, it's years. It's years because I told it years. And there doesn't seem to be a lot going on. You'll see up here in the upper left some circles, and then it says population size 100. But if you click on that, you'll find, oh wow, there's different people, it seems, in this population. It says 100 agents in there. But if you go over here to this navigation window, you can actually go down and you can find each successive agent in turn. How did I do that? I went over here, clicked here, and then I can go look at person 0, person 1, person 2, person 3. Okay? Just so you're aware, in computer science, we label things from 0. And this is a little bit of a mark of tension with mathematicians. A lot of us computer scientists are actually applied mathematicians gone bad. Well, okay. I won't put it down. They might think that way. But we basically do applied math. But one of the points of difference is we label from 0. Most mathematicians label from 1, and it's an interesting mix. I work a ton with folks in math, and it always requires some rejigging. So I'm going through person 0, and that actually will be relevant the next day or two. Person 0, 3, 4. But there's no differences seen right now. Why not? Well, they're all the same. They all have this certain location, the certain circle, and in fact their locations are the same. But we have a model that's running with the population. Okay, so ladies and gentlemen, what I'd like you to do now is we're going to introduce a wee bit of heterogeneity in terms of their position first, okay? But you'll notice that something weird happened with my screen. Can anyone see what's weird about it right now? This is an opportunity for learning. What's weird? Yeah, there's what's missing? The canvas. Thank you. The canvas is gone. Where is it? Whither has it gone? Well, you'll notice that over here on the right-hand side, and sometimes you'll see this in any logic, there's these things that says like restore, properties, shared area, restore. This is actually minimized windows. The canvas disappeared, the properties window disappeared. So you can actually go and restore these things. This says shared area, there it comes back. I can go here and I could say properties, okay, there's some properties. And I can actually drag these things around. If I want to reconfigure my space, maybe I want my properties to be down here, or maybe I want them over here. I want to see the properties underneath this, or maybe I want them over here as it was originally. You can actually reconfigure your windows, okay? You can also minimize that, and we'll get back to that sort of weird state. Well, it's not weird, it's just you got to know what it is. It's a state where they're minimized. It's a state where they're kind of off to the side. You have access to it if you want, but otherwise they won't get in the way, okay? That's useful. Let me show you one other trick that can be quite useful. Sometimes you want to focus on a window. You know, you're sick of kind of looking up and down here. Double click on this and it'll become the main window, okay? And now double click again, it'll go back to its normal shape. So you can zoom in, so to speak, and zoom out, okay? You can kind of get your focus and then come back to the whole. Make sense? Okay. Okay, so we just saw this, but let's, ladies and gentlemen, let's give these people a little bit of heterogeneity. Now, we're going to start with a particular simple built-in type of heterogeneity. We're going to work up from there, okay? Okay, so the first thing we're going to do is we're going to put in place a bit of heterogeneity for their location, okay? So we're going to go and we're going to put in place a situation where we're going to lay these people out in random X and Y locations. And it turns out that there's several different ways to do this in any logic. I'm going to take you through one that's a little bit more general, okay, and therefore which can be used in a wider variety of circumstances. There's a super quick way of doing it that will often carry the case, but we're going to come back to this way, so I'm going to use it right now. So in main, double click on main. We want to go to main, and we want to go to the population here. And I'm going to say place the agent here in a specified point, okay? So how did I do this? I double clicked on main, I selected population, and then I clicked on this initial location to expand it, and I clicked here, place agent in the specified point. Okay, so who needs help? Who needs help? Anyone? No? Okay. You see this? Does this stand before you? Okay. Now, here we have a location for X and Y, okay? And I'm going to put in a little formula for determining X and Y. In Java, we actually call it an expression, but it's we'll call it a formula here, and it's going to tell us what the X location is for someone in the Y location. Okay? People okay with that? Okay, so right now it's 0, 0. What did that lead to? When we viewed it visually, what was 0, 0? Where was that? It's up in the upper left of things. That's why they were all there. But let's give each person in this population, each agent is going to be given a different location. Let's give them the dignity of their own location, right? Okay, so folks, let's type here uniform. Okay, now I'll tell you a trick. Well, here, we'll just type uniform, and we'll say it'll go from uniform from 0 to 500, okay? So 0 to 500. Now, the perceptive young woman in the back will note that when I type these things, I tend to type them in a very specific way to try to make it clearer. And one thing is kind of putting spaces after a comma so you can just look at it and kind of see visually it's more spread out, not as crowded and cramped. So I type uniform 0 to 500. That's going to be the value for each person in turn. First person, the second person, the third person. The value for their x location will be drawn in turn from a uniform distribution, a continuous uniform distribution with a lower bound of 0 and a maximum of 500. Okay? People comfortable with that?
No, mine's not going to.
Okay, sure. Let's take a look. Okay, so if you go to population there, yeah, and then if you go scroll down, can you scroll down this? Yeah. Oh, okay. So, okay. Go up to the top. I'm sorry. Okay, so this is. Oh, I see. So what you're viewing here is the agent type. So click on that again. It's almost like it's selected. Okay. Click over here, just in the background, yeah, and then click there again. Okay. I think. Can we get rid of this guy? I'm not sure from whence it came, so I just want to go through the process of recreating it. And then I'd like you to drag from person over to there. Yeah, that's great. And then type population. Yeah. Okay. Good. Okay. And then great. Excellent. And name, agent type, okay, company selected, okay, I'm gonna have to probably come around, or is Annie free? No, Annie's not free, okay. Okay, okay, let me just take a look at that, okay, main agent type, yeah, okay, let me just go to this. It looks like your properties window is not updating here. Okay, yeah, it's just an issue with this properties window. Let me just close this. I don't know why that is. That's a strange thing. Okay, go to properties. Okay, there we go. Now we're cooking with gas. Okay, and now we're going to go here, and then you do population of agents, and we're going to do initial location, and we're going to do in the specified form. Okay? Okay, great. Okay, folks, sorry about that. Who else needs help? Who else needs help? Okay, so let's run it. What should we see now if we run this thing? Just with this specified. That's the only thing. What should we see?
People running around.
People running around? Word only so. What's that? They'll be in a line. Yeah, so let's go run it. They'll just be in a line in the what direction? The x direction. Okay, so they'll just be sort of located. Why are they all in a line? Why aren't they spread out vertically as well? Because we only specified it for the x value. So let's go specify it for the y value too, okay? So we're going to copy that same thing and paste it here. So in the y location, their y location will also be drawn between 0 and 500 with equal, according to a continuous uniform distribution with equal probability density. Okay, are people comfortable with that idea? We're going to draw the values. Now, I want to draw attention to you to one very significant point. And it's a point on which all of you deserve to be patted on the back. So you can pat yourself. And that is, you've just written your first Java code. Hey, okay, so this is actually Java code. In general, when any logic has you fill in values, you're putting in place what's actually Java expressions. They're formulas in Java. So this is a bit of Java code, and it's actually calling off to a value, to a function that draws a value from this distribution. Okay? And we're going to take advantage of this. I'll show you a quicker way that you can do something that would be quite useful. If I started to type uniform, maybe I didn't remember, how is it? I can go and I can press Control Space, and basically what's going to happen is it's going to give me a set of suggestions for things that start with that. So you'll see, for example, there's uniform here. By clicking on this and pressing Enter, it can fill it out. But on the other hand, there's also uniform discrete, and there's uniform pos here. Okay. So here we can kind of go see the different possibilities which apply. We don't have to remember them all from the top of our heads. Okay. We'll come back to documentation in a little bit, but just be aware it can be it is your friend, even though it may sometimes seem like your enemy. Okay, so let's go, having filled that in, let's go run this again. And what should we see now? Riddle me this. What should we see? Okay, we'll see laid out X and Y locations, right? So we've given people some heterogeneity, but we're looking for something more than that. But the point is there's 100 agents that stand before us. Well, okay, if you count me, it's 101. Okay. So 100 agents stand before us. That's great. Ladies and gentlemen, I'd like now to introduce a more a custom feature, something that's not built in. Let's go give each person in this model an age. Where do we go? Where would we go if we want to give them a specific age? Well, for now, we'll just make it a fixed thing. They'll have some age, which is a continuous quantity. Where would we go? If we want to say personhood, the theory of personhood includes each person having an age in our model. Where would we put that? Person. It's not in the experiment. It's not in main. It's each person has this characteristic. Each person has this property. So we're going to give it to them. If we have states later, each person has a state and they change between them, we'll put that in person. Person groups together the information, the characteristics, properties, state of that person, and the kind of behavior of that person. It groups it all together. Groups all of those together. So a given person kind of knows how to behave and what information they have. So double click on person, we come up with that. And we're going to add into them something that will encode information about their age. And we're going to add in this thing called a parameter. So please go to the agent palette here, and you'll see that there's a thing called parameter. Now, a parameter serves two functions. One function it serves is to encode this information. Another it serves is to actually communicate it from the point where that agent is, where the thing containing this parameter is created. So for a person, it will be in their population or places in the model where they're brought into being, where it says a birth should take place, for example. The parameter serves to communicate what the assumption should be. So a parameter encodes an assumption about this component of the model. So we're going to drag it into person, and we're going to call it age. Okay? And each quantity in the model is associated with a type, which indicates what sort of information it holds. A double means it's a floating point, a double precision floating point value. So it's a continuous value, conceptually. Conceptually, a continuous value. It could be 32.695. It could be 35.2. It could be 17.03. So it's an age. Okay? Okay. So ladies and gentlemen, we've given people an age in the model, and now we're going to specify an assumption. So we say personhood includes having age. It includes having a characteristic of age. Now we've got to specify for our particular population what age distribution or what that age should be. And we're going to draw it from a distribution. Does that make sense? So personhood has age. Would you like a bit of help? Yeah. Great. We're short-staffed right now. There's a high-level meeting going on. of which I do not partake. And that's robbed us of support. I'm sorry, the parameter. So you go to palette and you go to, oh, okay, somehow that got removed. So click there and you go to page agent here. And then there you go, there's parameter, okay? Yeah. Other questions? Okay, so folks, now what I'd like to do is we're gonna have to, for our population, give some ages to people. So go to main. Where does the population live? Whence does it live? Does it live in the experiment? Where does it live? In Maine, indeed. So let's go to Maine, double click on Maine. We'll go down Maine, and you click on population. And you notice if you click on population, there's something there. What is there that wasn't there before? Age. So we're going to specify for every person in the population what their age is. And you'll notice there's a little light bulb there. That light bulb indicates a hint to you. And what this hint is going to be telling us here is that it actually gives you, for free, sort of a bit of info on this person. So you're going to be putting in a formula to tell you for a given person how to determine their age. And here it says, well, if you want, you could use this thing called index, which tells you which person in the population they are, whether they're the first or second or 0th or 100th person in the population. We're not going to actually use that. But ladies and gentlemen, I'd like you now to have a uniform distribution, say between 0 and 80. Okay, 80 years or 85 years old. Okay, be uniformly distributed. No, it doesn't have to be uniform, folks. It doesn't have to be uniform. How many? Well, okay, we'll come back to this. I mean, would people really like to see how to impose a custom distribution?
Yeah.
You want to see that?
Yes.
Okay, you've had enough of uniforms, eh? It's a good thing you're not in the army. That's great. So let's impose a custom distribution. You want to do that?
Yeah.
Okay. As I told Jeff, things are scripted to a degree, but there's not a shortage of spontaneity. And so let's go at a custom distribution. Okay, so ladies and gentlemen, we're going to go to the palette. And look what lies before us in the agent palette. Does anyone see something of relevance? You see all these options: dynamic events, functions, events, schedules. But is there something that attracts your eye? Oh my gosh, a custom distribution. Okay. Believe me, this is not scripted. I actually didn't remember off the top of my head where it lives, but I was pleasantly surprised. Okay, so it lives there. So let's call it age distribution. What do you think? Good or not? Okay. Okay, so I just dragged this in here, and it's going to be the age distribution. What type is it? It's going to be continuous. We're going to define using frequency tables or ranges or observed samples. We could specify this in any number of different ways. Here we could say, okay, we're going to have some samples and draw according to those samples. We're going to sort of resample them. Or we could have a frequency tables of different discrete values, or some ranges. And this is going to tell us for certain ranges, certain ones will be more likely. So maybe, and I'm not going to spend a lot of time on this. The start interval from age 0 to age 10, maybe we have, and without loss of generality, I'll say 1. And then from age 10 to age 20, maybe we have, 0.9. Maybe from age 20 to age 30, we have 0.87, and from age 30 to age 60, the sort of relative likelihood per year of being in that range is 0.8, and maybe from 60 to 70, it's 0.7, and maybe from 70 to 80, to an upper bound of 100 say it's going to be 0.6 or something like that. Maybe I'll do it 70 to 80, it's 0.6, and then 80 to 100, it'll be 0.4. Okay? So this tells us kind of the relative likelihood, I believe on a per year basis, of falling into these sort of different age categories. So it's kind of like specifying a probability density function, where for different values of age, here's age here, most people can see this, I think, you're going to have, it's going to be sort of a different densities associated with these different areas. Yes,
Sorry, it's probably more conceptual question, and it's not the right time.
Yeah.
But just to understand a little bit more, you can argue that it's a population age distribution.
Yeah.
Or you can argue it's an agent that draws a random variable from the distribution.
That's correct.
Why do we decide sort of, there probably should be some sort of logic of why we specify the distribution at the main population level as opposed to an individual agent size? Because the positions, which is also an attribute of a person, is specified at the agent level.
Yeah.
Which is the
So this is a good question, and it's one I've heard before. Good question. So the question, I think, is the sort of at a conceptual level, the characteristic of this the values to assume for an agent. So we have agenthood defined by this agent, that it's that each agent has a certain degree of certain characteristics. They have an age, they can have a sex, that sort of thing, right? And then the question is, okay, where are their characteristics defined? Like, shouldn't their age distribution be defined with and placed not in main, but placed in the characteristics of the person? And I would say, for this model, it'll be equally good either way. But in general, if you have different populations, so I would argue that the age distribution associated with people is it's not an inherent characteristic of personhood. It's a reflection of different populations in which that person is embedded. So, for the age distribution seen here in Adelaide may be rather different from the age distribution in Hobart or the age distribution in place in Perth. And so different populations will have associated with it different age distributions, and sort of hard coding it within an agent as sort of an inherent feature of being a person is a little bit rigid in that sense.
But in principle, you could do it in both ways, so it's not that you. Like it would allow you to do it.
It would allow you to do it. Yeah, sure.
Because in principle, the question is why the location as an attribute.
Yeah. It would. Yes, it would allow you to do it.
So
I would have to show you some technical finesse because it would be an aspect not of a particular agent, but of it would be an aspect of agenthood that would be defined before we have the first agent in place. And so there'd be a bit of technical finesse there. But could we do it? Yes, I could do it. But I would feel abusive at doing it to you at this early stage, okay? Okay, so we have an age distribution. Are people okay with that?
The number of observations, is it always arranged from 0 and 1? Or?
No, it's a relative value. It's a relative value. We're defining here probably density function, and it's saying sort of the relative likelihood on a sort of per year basis of falling in different ranges, and we are basically imposing that, and these are relative values. Conceptually it's gonna normalize them. Forgive me if I'm using terms which are unfamiliar to people, but it's gonna conceptually, whether this was 10, if you multiplied all these by 10, it would be the same thing. Is that helpful? It's just kind of the fraction if you added these. Yeah. I mean, it's multiplied by all the 10 would be the same thing. Okay. Other questions? So, ladies and gentlemen, having defined that age distribution, let's go draw from it. You wanted me to do that, so I did it. And now we're going to use it, okay? Is that okay? Yes, Roberto.
Yes, a question. I made a mistake and I changed I put a wrong interval.
Okay.
How can I create a new interval?
Oh, okay. So Roberto had an interval.
10 to 13, and then I want to change 10 to 20 and 20.
Right. Okay. That's a good question, Roberto. Annie, maybe you could. Here we go, Roberto. See, there's an X under here. See that? I can go and do an X, and that will eliminate that whole row. Okay? The X just below the table. It will allow you to edit that. Okay, ladies and gentlemen, so let's go draw from this distribution, okay? Okay, so we're going to now have to specify for this population an age for each person. Do people see that? People okay with that? Okay, so let's go draw a value. You were sick of uniform distributions. So let's go get a value from this age distribution. What you're going to do, started typing age distribution, and you'll notice there's this thing, you just call it. This is what this parentheses mean. Do you remember a long time ago, well, perhaps for some of you, not a long time ago, perhaps even for some of you still in the future, do you remember being in a math class? Okay, don't run out the door, okay? Dylan, can you close the door? Thanks, Jeff. Okay, do you remember writing something like sine of 30 degrees? Something like that, or maybe you did sine of pi radians or whatever. Believe me, I'm not going to force you to do that. Okay, sine squared plus cosine squared. Wait, no, I'm not going to get you to do that. Okay, but this is you're taking the sine function, you're applying it to 30 degrees, right? You're saying what's the value of that, and that's what these parentheses mean. Like when you have those parentheses after something, it means call it using this. But in Java, if there's nothing given to it, we still have to use them to say give it nothing. There's nothing to be given to it. It can do its job without any information. So there's this thing called age distribution. We'll just call age distribution. It will grab us a value from that age distribution. Does that make sense? Yeah. Yeah, it's right there, and it's in age up there. Yeah. Okay. Are folks feeling okay? Okay. Some help here. Okay. Yep. Okay. Yeah. You put the age distribution in person. You need to put it in. So go. Wow. You have it in mainstream. Okay. So there it is. Go click on that, and then you'll put it there, right there. Yeah. Yeah. Okay.
Can you put an I or something in there? Because you mentioned index.
Yeah. If you want to use it, you could use it. For example, you could have different age distributions. But you could have based on the index, you set their age. So the first half of the population is young, the second half is old, based on index.
It's not 1, 2, 3.
No. Oh no, index is the person 0, person 1, person 2. Their label in there. So you could have the first 50 people be of age 10 and the next 50 people be of age 20. Yeah. Okay, folks, so can we run this thing? Let's run it. Are you ready? Are you ready? Okay, so ladies and gentlemen, let's go to this thing up here which says build model and press that and make sure it's copacetic. It should say build completed successfully. By build, it means it's checking the model. It's making sure it's ready to run. It's ready to go, okay? And if you do build, that's going to be your friend. It's going to tell you if there's a problem, if it doesn't understand.
Where's the build button?
Sorry? The build button is this guy up here. It says 010 on it.
Yeah, thank you.
Yeah.
What if you don't do it? It will automatically do it.
It will build it automatically, but then it's often you want to do this without running the model. So like I will reflexively talk about best practices. I'm starting to shout, and I can only shout for so long, I'll lose my voice. So, with the build function, I reflexively build, after every significant thing I do, I just build, and I might not run it at that time. I might not run it for a while, but I'll build. Build early, build often. Okay? This is how it tells you if there's a mistake. And believe me, folks, it's much, much easier to deal with a mistake if you catch it soon. Because if you don't catch it soon, you may compound it. There'll be more and more cruft built up around it. The more and more things you'll have to redo, but maybe more to the point, there'll be more weird error messages. So if you build early, build often, build very frequently, maybe there'll be one mistake, and you can go easily find it. You can go easily correct it. If you're building only infrequently, there'll be, 6 of them, I don't know what to do. They're all weird messages. Yeah. Okay. Yeah. Age distribution. Okay. No. Okay. Method age distribution is okay. Okay. That's really interesting. No. You know what? Okay. Could you try? So that's really interesting. I would have expected that to work. So can you? Maybe it's misspelled. Oh, you know what that says? Distribution instead of distribution. Ladies and gentlemen, you'll be less Oh gosh, I gotta watch my voice. I gotta figure out a way to get this thing. You'll be less subject to spelling mistakes. If you do control space, it will sort of, instead of copying down what's on the screen, you instead do control space, it will do it for however you spelled it. Okay, so if you didn't have a capital D instead of a lowercase d, it'll find it for your thing. Okay, okay. Other questions? Okay, so let's run this thing. Okay, so we're going to do run here, and here we are. And what's going on? You see anything different? No, there's nothing different visually. How could we go see each agent and see what their age is? I told you earlier, I showed you earlier. Yeah, this thing, it's a drop down. Here, we can go here, and here we'll see there's someone of age 64.1. Okay? Here we'll go 9.6, 40.4, 65, 66.5, 54. Okay? So here we have agents with different ages in the population. You could cycle through them and see their ages. Okay? Okay. So when it shows them there, it's just showing them relative to kind of where they're positioned. So the old version of AnyLogic used to show them all around, actually, if you did it. But for whatever reason, they just decided to not kind of visually show them as kind of where they are on the screen, rather just always puts their visualization up there. I personally don't like it. So this is always shown relative to their position, where they are. But like this person here, person 3, will be one of these people out here. And we'll find ways to do that. Okay, so are people comfortable with that? Okay, now let's start to have a bit of fun. Okay, so ladies and gentlemen, let's go. We're going to make a person's, the width of a person's circle depend on their age. Okay? What do you think? Good or not? Good. Okay, great. So what we're going to do is, where would we define the characteristics of a person? Is that a name? In person. It's in person. Okay, so let's go to person. Okay, now let's go to their visual representation here. Okay, that's good. And now I'd like you to go to the place that says position and size. So we went to person and we want to set a property, their visual representation. Let's now go to position and size here. And we're going to make it so the position, the size of this oval is going to depend on their sex, or excuse me, on their age. Okay? People okay with that? Okay, so how are we going to do this? Well, down here, there's a thing called radius. And I'd like you to click on this and go to dynamic value. Okay? So it was originally an equal, which allows you to put in fixed values. And I'd like you to say dynamic value. Okay? So it's now this kind of thing that indicates it's updating. What's that?
But here we also have an option to change the position, the X and Y for the circle. So is there, could we do it here instead of doing that with the age? Is there any difference?
Yes, it's a good question. This is defining the X and Y location of the particular circle. The other one is defining the agent's logical location. And those are two different things. The agent has a logical position in space. This is saying where their appearance will be located. So where their kind of visual representation. Okay? I hope that's of help. Okay, so ladies and gentlemen, I'd like you to put here for this value a number, okay? And we're going to say radius will be the log. I'm going to make it the log. Okay. The log of 1 plus their age. But I'm going to multiply this by 5. 5 times log 1 plus age. That's so if they're age 0, then they'll have, well, the age 0 it'll be microscopic. It'll be 0. But it'll always be positive, the log, or 0. Yeah, 0 or positive. Okay, non-negative. Okay, so I said 5 times log of 1 plus age. Okay, might space it out a bit. Okay, and the spacing is immaterial, but it might make it a little bit more visible. Now, do you folks at the back have trouble seeing this? Okay, so what I'm going to try to do then is to have some option of showing this on the big screen. Can you give me just a minute? I'm just going to see if I can change the fonts here so that the fonts are larger. Yeah, there's no, okay, gosh. I could do it with screen resolution, but I don't want to futz with that right now. What I'm going to do is, for the moment, I will go and do it in a notepad window. Okay, and I'm going to make this larger. Okay, there we go. Okay. Okay, are people comfortable with that? What do you think should happen when we run it? What does it look like?
I want to say something.
Yes.
Make sure you're in person and not make sure you are in the person tab.
Yes.
Clicking on the circle, not in the name tab.
That's right. This should be in person. You can easily get confused because there's a circle in both. The circle in the main indicates where the kind of origin is when you display all the people within main. This one actually is kind of the properties of each person in turn. Okay? So I'd like you to run it, and you should see something like this. What are the bigger square? What are the bigger circles? Those are older people. What are the smaller ones? They're younger, right? They're younger individuals. Okay. Great. So we've just introduced some heterogeneity, but let's go further than this, folks. Okay. So I'd like now to introduce sex as a characteristic. Okay? Now, what are some common ways that you, in a data set, will encode sex? Sorry? 1 and 0. That's good. Some people might 1 and 2. Now, we could do that. And in older versions of AnyLogic, I used to do that quite commonly. But there's an issue here. If you encode it as 1 and 0, maybe you encode the Australian state in which someone's located as 0, 1, 2, 3, 4. I don't know how many states there are. What, 8, 7? How many? 6? Okay. Sorry. And then there's the ACT, and in any case, 0, 1, 2, 3, 4, 5, 6, or something like that. So you can encode it, but then if you see a 0 in your model, what does it represent? Does it represent male? Does it represent female? Does it represent the ACT? It's not really clear. You could do something silly like assign a value that was meant for sex to the state, or vice versa. So it's easy to make mistakes. So AnyLogic has a very nice mechanism that is used to really reduce the chance of it, called an option list. So I'd like you to right-click on the whole project and say New Option List. Okay? And I'd like to create an option list called sex. And the elements of sex will be female and male. Okay? Those are the two attributes, the two possible values of sex. So someone's sex will be set by one of these two values. Will be associated with one of these two values. Okay? So that defines the sort of possibilities for their sex. Okay? How did I do that? Do you want me to show that again? How I did that? Okay. So I right-clicked here, associated with the whole project, because I'm adding something to the whole project. I do New, I do Option List, and I say Sex. And I'm going to say female, and I'm going to say male as the sex of each person. Is that okay? People okay with that? Yeah. It is case sensitive. So lowercase male, it'll say no go. I don't know what that is. Uppercase male. So it is important, and by that token, Joachim, per sort of best practices, I'm very consistent. And if I create an option list, which is a common thing, I will name each of the things with a capital. And I'll give the whole name of the capital list a capital. So if I see it, now you could argue, you could say they should all be lowercase. That's fine too. The first letter should be lowercase. I could live with that, but I would say the name of the whole thing, the sex, should definitely be capital by conventions. The ones within it, I think normally they're capitalized, but I don't have a dog in that fight. I'm okay either way. But you should be consistent in your standards, so that when people see it, they'll know what it is. Yes?
And judging by the logic that it creates in the main, rather than sort of the project rather than the person, it looks like it's going to be potentially applicable to other agent types equally.
Oh yes, totally.
Okay, so it's going to be.
It's nothing to do with being specific to person. It's in no way contingent upon person. Or you could have you could have a doctor type. You could have a household type. You could have a neighborhood. That's right. That's right. Yeah, yeah. You could have a deer type, and you could apply sex to that deer. Yeah. Okay. So we're going to say finish here, and so now we have this option list sex. Okay. And now what I'm going to do is I want to associate each person with a particular sex. So personhood is going to also include their sex, okay? So how would I, building on what we've done before, how would I add a kind of an attribute, a characteristic of this person? Pretty much static here. That's for sex. What would I do? What did I do to do a similar thing before? I added a what? Parameter. Yeah. Okay. So let's go do that. Where would I go find a parameter to add? Wherein do I look? In the palette, in the agent palette. Good. Drag in a parameter, and I'm going to call it sex with a lowercase. Okay. This is the sex of the particular person, just like age. It's a particular value for it. It's not sex as a concept. That I gave with a capital S. It's sex as a particular sort of instance of it, a particular person's sex. So we're going to call it sex. And what type is this going to be? Is this going to be a double precision value? No, it's going to be something that's of type sex. Okay, so it's type sex, capital SEX, the concept sex. Okay, does that make sense? Okay, that's great. That's great. So who needs me to rehearse one of those steps again? Because I'm going pretty fast. People feeling okay? Okay. Okay. Annie sits and waits. She's ready to help someone. No one needs help right now? Okay. Okay. So, ladies and gentlemen, where do we, pursuant to Leonard's question before, where do we before specified a distribution for people's ages. I argued that different subpopulations, Sydney, Hobart, Adelaide, Canberra, each of those is associated with a different age distribution. And therefore, where do we specify, when we needed to specify the age for someone, wherein did we do that? It was in Maine, and what thing in Maine in particular? It was associated with the what in which the person was located. In the, it begins with P, population, good. It was in the population, and so it is with their sex. That's what specifies. Remember I said parameters, ladies and gentlemen. Parameters, I said, serve two purposes. One is to kind of encode assumptions, like about each person, and another is to communicate those assumptions to that agent from the point they're created. And where are they created? They're created by, in this case, by the population. So here, associated with the population, we specified their age, and we're going to specify their sex. Okay? Okay? Now, there's many ways we could specify this for sex. Let's do it this way. Okay. Okay, ladies and gentlemen, I think actually there's forgive me because I'm doing this off the top of my head, but there should be a really quick way to do this, and I believe it's this. Random from, yes, exactly. Random from sex, and I think you have to do sex.values. Let me just, I build, oh, look at that, it's got a problem, okay, yeah. Okay, fine. Sex.values, that's what we want. The set of possible values for sex, we're going to pick a random one of them. Let me put that up on the big screen for the folks at the back. There we go. So, okay, random from, you're picking one with equal likelihood from a set of possible options. What are those options? It's the values possible for sex. Now, notice these parentheses. These are just like this sine of 30 degrees. They're saying, okay, compute a random value from this thing, just like this is saying, compute the sign from this information. Sex.values, it's the same function, but it doesn't need anything provided to it. So there's just this begin paren, end paren. It's like nothing's needed for it. So just do it. Just do this job. But you still have to do the begin paren, end parens because you have got to tell it, go off and do it. Do it. Okay? Okay, who needs help? Help over there? Okay, yes.
Just a question that might be better for later, but if we wanted to draw, say, a joint distribution between sex and age, is that readily done, or is that something we need to go
Yes,
through?
it's readily done. And what you would do, and in fact, we may be doing that in just a minute. Right. Okay, so actually we're not doing that here, but basically the simplest way to do it is to make a conditional distribution. So you have a marginal and then a conditional. So first you draw their sex, and then you can make their income dependent on the sex.
That makes sense.
Yeah,
Thank you.
yeah. And that's very straightforward to do. Just be aware that, and I'm sorry to have to tell you this, but just you'd want to add their sex before you add their income type.
That makes sense, otherwise you've got to.
Otherwise, it's the other order. Because the one that gets added to the agent first, in other words, the one that you dragged into there first, that's the one that's computed first.
Oh, okay, so the order in which you do operations is the order in which...
Well, the order in which it initializes each of those is the order in which you added them. So what it could mean is, if you did it the wrong order, just delete it and then paste it back. Yeah. Okay. I could do that. We do that in some exercises online. You'll find me doing that. Okay. Okay. So, folks, do you want to run this thing? Okay. Run or not? Run. Okay. Okay. So let's run it. Okay. Oops. Whoop. Let's go right-click, run. Okay. Okay. Great. Okay. Now, where are their sexes? If we want to see the characteristics of each person, whither do we go? Yeah, we go to the drop-down. We go to this navigation. Okay? And here we see there's a female of age 64. Here we see that there's a male of age, 98.7, a female of 25, a male of 21, a female of 61. Okay? Yes?
I entered details for sex and age distribution, but when I read the model again, I didn't see the change.
Okay. No, but if you go click here, we're gonna be. Oh, I see. Go click there. Okay. So each person will click up, and each person has a different age and sex. But you want to see the presentation never change. Okay. So close this thing, and then go to person. Double click on it. Okay. Go click on this. Okay. And now go to. The oval, and then you go to radius. This is what you needed to set. You have to click on that thing there. Oh, no, go click on this equal sign. Yeah, but if you go, okay, put 30 back in, and then go click on the equal sign and drag it down, new dynamic variable. Because right now it's not set to do a dynamic there. And value editor. Yeah. Okay, that's weird. Yeah, sorry. Let me just take a look at that. Sorry, folks. You'll be right there. Okay. So you're going to do 5 times log of 1 plus age. That's what you want. Now you should be able to run it and see it. Okay. Try running it. Okay. Raise your hand if you don't see that. Okay, so folks, should we make their color depend on their sex? Okay, so visually we can see. Okay, so ladies and gentlemen, how would we set the color of an agent to be dependent on sex? How would we do that? How do we make their color, as depicted by the oval, how would we have it depend on their sex? Well, before, what did we set about that oval? We set what about it? The radius. And where do we do that? Where do we go to do that? Did we go to main? Did we go to the experiment? We went to person. And where in person? Whither did we go? We went to the oval, did we not? Okay, so let's go to their oval once again, and let's set its color. Yes. Oh, that's fascinating. Okay. Okay. Houston, we have a problem. Okay. So. What happened?
You threw an error earlier. You might be trying to open up the area where you put the stuff in there, throwing it out, and then she reset it up, and it's not showing the area.
Okay. So this is going to be exciting. Did you close any logic and reopen it? And it's still having the issue. Very fun. Okay. Okay. We have 2 choices. So my preference would be to fix this during the break in a few minutes. Okay. Is that okay? Because otherwise I can do it while I'm talking up here. Okay. Okay. Okay, so folks, go to person, and I'd like you to click on the oval, and then I'd like you to go, and we're going to set the color associated with this oval. Where do you think that lives? Can anyone tell me?
Appearance.
It will be in appearance. Okay. I've got to hang this thing from my nose or something. This is going to be really bad. This is really bad. My throat is killing me. Okay. Okay. Let me. Okay. Okay. I can hold my head at a strange angle. Okay. So we're going to click on this guy here, and we're going to have the fill color. So where did I go? I double-clicked in person. I went to the oval because it's the characteristics of the oval for a person. I went to person because we want to change the appearance of a person. I went to the oval within a person because it's the oval whose appearance we want to change within that person. I went to the appearance section of the oval because that governs the appearance, including the color of that oval. I went and I set fill color, and I changed it. Mark my words here. I changed it from something where it's preset to something, and hence this equal sign, to something where it gets computed. Now I want to set the color to be determined by the person's sex. Okay, now we're in new territory. Okay, so what I'm going to do is I want to say I'm going to determine a sex for this person. If they're female, they'll be one color. If they're male, they'll be another color. Let's make female yellow and male gray. Is that okay? Okay. Female yellow and male gray. So we're going to need to put in a formula that says, well, if the sex is female, make it yellow, otherwise gray. So I'm going to tell you a way to do that. Okay. It's going to be a little way you write a formula that will do that. It's going to be like this. If the sex is equal to, I do two equals because it's testing equality. It's not setting sex to be a value. It's testing whether it's equal to female. Okay. If it's female, then we will use the color yellow. Otherwise, we will use the color. We'll use the color gray. Is it G-R-A-Y or E-Y? E-Y? Okay. Okay, thank you. Like Earl Grey. Okay, now there's a problem here. Okay, so maybe does it say A? Yeah. Okay, there we go. It's with A, which is probably what was said. I just misheard it. So do you see that? Let me go put it up in the big screen. There we go. So let me parse this for you. It's just the way of writing it in Java. This is kind of its rule for saying if it's this, do this. If it's this, it's this value. Otherwise, it's that value. If this thing is true, if the sex is female, that's what that equal sign means. If the sex is female, if that's the case, use yellow. Otherwise, hence the colon, use gray. Does that make sense? That's just its way of writing it. It's it just kind of, that's how it understands it. Okay.
Do you need a bracket, or will it work without the bracket?
You mean that like sex equals yellow? Equals female? Yeah. So you're saying could it work like this? Yeah, it would work probably. It's just that I don't. So there's a rule called precedence, and the question is, would it interpret it like this? In which case, it's going to cause a problem, or will it interpret it like I meant it to interpret it? And in general, it's better to be explicit about it. It's better to be clear about what's meant so you don't leave anything to chance.
Why would you put the male in? Why do you do it? Because it's a yes, no?
I'm sorry?
then why not just say sex is yellow, then male is gray?
Well, because in this case there's only two possibilities. So if it's female, it's yellow. Otherwise, it's gray. But excuse me. There's an extra parenthesis at the end here that I didn't mean. But I could have made this, if it's male, then make it gray. Otherwise, yellow. Would be another way I could have phrased the same thing. But could you do it? So you say, if it's female, make it gray. Is it male? Make it yellow. Otherwise, get upset, or something like that. Or otherwise, make it, make it some other color. You could, but because there's only two, I just did it for this for use. Okay. Okay, that's a good question. Java is case sensitive, but in this case, this is what we want. Why is it what we want? Because I'm testing the sex of this particular person. Capital sex, that indicates the concept of sex. It's sexhood, as it were. It's sort of the set of all possible sexes. But in this case, we're testing for this particular person, am I female? If so, I'm yellow, otherwise I'm gray. Does that make sense? So it's lowercase because it's referring to this thing here, which is lowercase. That's why it's one of the reasons it's important to be consistent about this. Is that okay? Do people want more time with this, or do you want me to come help? Do people want help? Yeah, Roberto. Okay. Yeah. People want help? Okay, yeah. Yeah. Okay. So, people can run the model. Please be encouraged to go and run it and see what lies before you. Okay. Yeah, let's go see what's going on. No. Oh. This should be, that's why. It's still copying. This should be capital S because it's a set of all possible values of sex. Okay? We're choosing from those. And then you're going to want to build this and see if now it's a happy camper. Okay? Okay. One more happy camper. Okay. Yeah. As a concept. Okay. Okay, so it's a great question. So there's a question. Sorry. Okay, so there's a question. How do I determine whether I need a capital SEX in a given place or a lowercase SEX? So capital SEX is associated with the set of all possible sexes. It's defining kind of the concept of sex in the model. And that's defined in one place. It's defined here as an option list, and then we are using it in one place in the model in this population and saying, okay, choose a random one from there. So this is referring to kind of the set of all possible sexes and tell me all their values, okay? Whereas in a particular context, I'm dealing with a person and they have a specific sex associated with them. This sex is an instance of, it's a particular value drawn from the sort of set of all possible sexes, but it's a particular sex that they have, that they carry around with them through life. And that SEX is always associated with the lowercase, okay? I don't know if that's helpful, but I'd be glad to show examples separately. We're going to have to get towards a break here, so let's let me just reflect on what we have to do. Okay, great. Do people want to see a situation where we have a sex-specific income distribution? You want to see that? Okay. Right, exactly. Thank you. Okay. So we're going to need to do a little ritual here. What we're going to do, so the question was asked earlier, and it's a great question. How do I impose a joint distribution on income, on income and sex, so that, you know, one sex has say, a higher income distribution than another, or vice versa? How would I do that? Well, the easiest way to do this in any logic is to decompose it into a marginal distribution and conditional distribution. So you could have age, sex, ethnicity, and you know there could be a distribution for maybe sex first, and then you make the distribution of age contingent on sex, and distribution of ethnicity contingent on age and sex successively. So what we're going to do here, folks, is we want to go to main, we want to go to population, and we want to set it so that the we're going to have age, we're going to have sex, and then we're going to have an income associated with this as well. And how are we going to add an income to this model? We want to add a parameter. It's a parameter. Later, we're going to be seeing things that change, but this is a parameter. It's something that we're going to view, for the sake of kind of theory, as sort of only being changing occasionally. So we're going to drag from parameter into person. We're going to call it income. Notice this is in person, okay? It's in person, okay? So I double-clicked on person, and then I went to the palette, and I dragged from the parameter into there for their income, okay? People okay with that? And we're going to leave it as a double precision value. I mean, we could try to impose something on it. We could say, you know, it's a currency or something. We're just going to say it's a double, okay? Okay, that's great. Now, ladies and gentlemen, so that occurred to person. Anyone need help with that? Okay, so now I want to go to impose a distribution for income. Where would I do that? An income distribution is associated with a population. Thank you. Because maybe I have two populations, one for Canberra and one for Adelaide, and each of them has a different distribution. So it's associated with this population in which they're associated. So let's go to the population, and this is where we specify the income. Okay? Now, we want to specify a different income distribution for men and for women, because unfortunately there remains quite a lot of disparity. Even for the same job, oftentimes women are not paid nearly as well as men, in the States at least. And the gap is less big, I think, in Canada, but is still there. So let's see if we can capture this. So for the income, I want to impose an income distribution, okay? Great. So first let's impose one income distribution. Let's draw it from a log normal distribution, shall we? Okay, because it tends to have a long tail. There's some people who have very, very high incomes, but even though the median may be quite smaller. Okay, so let's impose for the income, let's first impose a log normal distribution. Okay, with a mean of a log mean, a mu of 10.5, a standard deviation of 3.5, and a minimum value of 0. Okay, it has a sort of a minimum. So this is a log normal. Let me put that up on the big screen. Okay, there we go. It stands before you. The value. So what is this saying? It means for each successive person in the population, person 0, person 1, person 2, it's going to be drawing a value from that log normal distribution, right? Each successive person in turn, it's going to be calling off, and it's going to say, tell me a log normal value and log normal needs some information to do its work. Where is that information specified? It's specified in the values, yes, of 10.5, of 3.5, and 0, which we call, confusingly in Java, we call those parameters. Those are parameter values. They're also called arguments. Although there's a semantic, there's a distinction actually between those, but you'll heard them informally called that. Let's call them arguments here. So these provide the information needed for log normal to do its work. Okay? So it's going to draw a log normally distributed value with mu 10.5, sigma 3.5. Can we run this thing? Run or not? Okay. But I want you to tell me. I want to change it so that instead of their radius visually, depending on their age, I want it to depend on their income. How would I do that? Where do I go? Whither do I go? Okay, I go to person, because this has to do with a person thing. It has to do with a thing for each successive person. Where do I go in person? I go to the oval, because it has to do with an oval thing within the person. It has to do with their presentation. And where do I go here? It stands before me. Radius, good. Okay, so let's change this to be, instead of 5 times log 1 plus income, let's make it 2 times the log of 1 plus income instead, okay? Okay, great. I'm doing 1 plus it because I don't want 0 income to lead it to it's not going to be 0 with log normally, but I don't want also sort of the log to be negative and weird thing. So I just want to make it 1 plus income. Okay. Okay. Can we run it? Do you want to run it? Yes. Question.
Were we making the income dependent on sex?
We're going to in just a moment. Just a moment. Well, just one step at a time. Okay. Okay. Great. Can we make it? Can we run this thing? Run or not? Okay. Okay. Who needs something done by me? Do you want me to show you something? Okay. There we have before. What do the big ones now represent? Higher incomes. Smaller ones represent lower incomes. Okay. Great. Great. Ladies and gentlemen, now I'd like you to. Now we're going to have the denouement. We're going to have the crescendo, okay, towards which this model has been building, okay. It's going to be now the final magnum opus of this session, okay. We're going to impose a sex-specific income distribution, and the heart of it, the highlight of it, is that you're going to tell me where to go and do it. So where do I go? Whither do I go? Okay, so we could go to person, and that would be a good thing because it has something to do with persons. But you know, perhaps the gender disparity is lower in Stockholm than it is in Atlanta, Georgia. So it's actually going to vary. This disparity is going to vary by what? By population. So we're going to actually go, in terms of the specific values to assume by agents, those are specified by the population. The theory of agenthood, you know, what it means to be a person, that's what's in person. How their appearance is, how they behave, what characteristics they have. That's one for person. The particulars to assume about them, that's specified by the population. So let's go to the population. Wherein does the population live? Does it live in the experiment? No, it lives in Maine. That's right. Okay, so we're going to go to the population here, and we're going to go to where it says income. And you're going to tell me how to modify this so that if this person is female, I'm going to use one distribution. If they're male, I'm going to use another. How would I say that? How would I tell any logic? Through the sort of somewhat uncomfortable conduit of Java. How do I tell it? If it's this, do that. If it's this, use this value. Otherwise, use that value. Where have we seen that before? Yeah. Great. Yeah, that's exactly right. That's exactly right. And a thing of beauty it is. So well, I don't mean the disparity. I mean the Java code. Okay. Okay. It's a thing of beauty that you can mention that. Okay. Okay. So I'm going to put it this way, and there's actually a slight fly in the ointment, but we're going to deal with that. If sex, and how do I say if the sex is equal to female? Do I just say sex equals female? I need a double equals. Okay, look at this burgeoning room of Java programmers. Man, do you want me to get Silicon Valley on the line? Okay, so something like this, if sex equals female, we're going to impose, oh, what do I need here? Is it a colon or a question mark? Okay, good, excellent. It's a capital F because in sex it's capital, well, it's whatever you use there. If you did capital M for male, capital F for female, then it will be what that is. It's however you used it. So I'll just switch to that so you could see what I mean. I did male and female and male. That's why I have to do capital F. It is case sensitive, okay? So let's go back to population. Okay, so here we go. So there's a question mark, and I give one value, and otherwise I'm going to give another value. Now I'm just going to start with copying this thing, which is going to do nothing because they're both drawing from the same distribution. But I'm going to change the first to be 10 and 3 and 0 for females. So there's a lower mean, lower standard deviation. And then I'm going to make this 11 and 4 and 0 for males. Okay, let me put this up on the big screen. So this is wrapping in an unseemly fashion. Let me see if I can, oh gosh, not that. Okay, there we go. That's what it is. Except there's a fly in the ointment. And the fly in the ointment is an uncomfortable thing that I'm going to have to tell you. It's going to say sex cannot be resolved to value. The thing that you have to say here is you have to say self.sex here, okay? Just in this very specific case of doing these conditional distributions here, when you're setting the initial values for a person, you have to say this to mean my sex here, this particular one I've just said. I'm sorry to tell you that, and I feel like slinking out the door right now, but that's the truth of the matter. Yeah, if you're going to refer, if this thing is going to refer to earlier ones, if it has to refer to their age for this particular person, it would have to be self.age. Okay, it's just, yeah, it's a little ritual you have to go through, and it'll be the first of several rituals they have to go through for the Java compiler. So I'm sorry to say that, but such is our lives as computer scientists. Yes, question.
So also is a Java question. Can we call it from the person, saying like person gets sex, or I'm not sure what is the right way of saying it.
Well, the person isn't created yet.
No, when you use the self and then you call it from the person.
Okay, yeah, the reason this is a little bit obscure is because here we're telling it how to create the person in the first place, so that person may not exist yet. Yep. And so we're saying the values you will use for this person to be created are as such. And we're giving it their age, we're giving it their sex, and we're giving it their income. And their income is contingent on sex. This is a conditional distribution that we're specifying. You know, conditional on being male, it's this distribution, otherwise that distribution. Conditional on being female, it's this distribution here. So that person doesn't exist yet, and yes, you could. The short answer is you could do it after the person's created and pose it, no problem. It's just that it's a little bit easier here. I just feel like you shouldn't be subject to this indignity, and we're working to subject you to fewer indignities, okay? Dylan is working hard. Where is he? He's, yes, okay, yeah, he shows solidarity with the cause. Yes?
If you
Yes.
How would you write that? Like three categories, how would you write that code?
Yeah, it's a great question. We would use a very important principle of computer science known as recursion. So what we would do, you want to see how I do it? Okay, you promise not to run out. Okay. Okay. Let me just let me copy this there, just so we have a copy of it. And this is what I did, folks. I did self.sex instead of sex, and that's our expression in all of its fulsomeness of its glory. And let me just show you what I do. Do you want to see it? Okay. So suppose we had ethnicity, and we wanted if ethnicity equals ethnicity equals Caucasian, then we want one thing. Otherwise, guess what I'd put here? So if it's not that, then I would just put another one of these. So I say otherwise, if the ethnicity equals, I don't know, Asian, use this distribution. Otherwise, use a distribution for everyone else. Da 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 da. And so all I do is I say, okay, is it this? Use that. Otherwise, is it? If not, is it this? Use that. Otherwise, use this. That would be a brutal way of doing it. That's straightforward. It is a natural extension of this. But what I'd actually do, the truth of the matter, if I wanted to do that, I would create a function, and it would say get income for ethnicity, and I would hide that because I stand before you as a computer scientist who's probably written 500,000 lines of code in my life, and I hate looking at complicated code, particularly code that's unnecessary and gratuitously complicated. It's an abuse of people's time. Is it not, Dylan? Yes. And so what you want to do is you want to, in your model, if at all possible, wrap things up so that people don't need to see complexity unless they have to. And by my token, this is an abomination. It's too complicated. You look at it, and yes, someone who's really experienced can look at it and say, oh, okay, I understand what's going on. But someone who's really experienced and has a sense of aesthetics will look at that and say, yeah, I see what's going on, and that's hideous. Let me go hide it in a function. So that, and it would just, all it would appear, it would be a thing of beauty, and I'll be with you in just a second. It would be a thing of beauty. All it would say is, get income from sex. It would specify the person's sex, and that would be it. And then if you wanted to go look at get income from sex, then you could go look at it, and it would be a nice little function that would compute it. But you don't have to look at it unless you need to. So if there's lots of cruft in your model, like things that look complicated, it's probably a sign that you're not really tapping the best way to do it, okay, in general. But that is a way to do it. This is a way to do it that's basically just building on this approach. If we have to go beyond 3, I would exhibit signs of distress and displeasure, and I would feel very uncomfortable. 3 is at the extreme limits of my tolerance. Yeah, not every computer scientist has it. Software developers, software engineers have this aesthetics. Don't look to everyone. Some people have it, some people don't have as the aesthetics. So don't expect everyone will necessarily carry that prejudice with them. But it's a prejudice born of long being burnt so many times in my life that I just have little tolerance for unnecessary complexity. I think Dylan's on the same boat. Thanks. Okay, so should we run this thing? And then we'll go for a break? Break or not? Okay, so let's run this thing and hope it doesn't break. Okay, so I just built it, and now let's run it, okay? So yeah, it could be beautifully done with a function. It would just be elegant and wonderful. Okay, so here we have this thing, and that's right, I have a question I'll get to in just a second here. We drill down to the population. Here we have different incomes for different people in the population. Here's females with income. I mean, there are some high earning females. It's pretty significant. But by and large, we're going to have incomes that are distinct for males and females, quite distinct. And this is all I plan to give here, but would you like to see one final thing? It will take about less than 5 minutes. We could actually have it print out statistics on the average income for males and females. Do you want to see that? Okay, let's do it. This is really quick, and it's a thing of beauty in AnyLogic. AnyLogic deserves great praise for supporting this functionality of statistics at a high level. And I'm going to make one final point about this, because what you're seeing here is some points that are very powerful that I want to explain. So, go to the population. Where does the population live? Is it in the experiment? It's in Maine. Okay, so go down Maine, and then click on the population. Okay, and you'll notice there's a tab or a little expandable area. Do they call these accordions? These expandable sort of zones. The expandable zone, and you'll say it's in the statistics. You, in AnyLogic, you can define your own named statistics. You could say, make me a statistic that computes the average of this or the maximum of this, sum of this. We're trying to get them to do median as well, because that's very important, as you know, for certain needs. So in the population, I'd like you to click Add, and I'd like to create mean population, or mean income, okay? Or average income, okay? This will be the average income over the population, okay? And watch this. What do you think we do here? What do you think we do? If we want to compute an average, which do we select? Would we select max? Would we select count? Average. Okay, good, excellent. And now we're going to have to tell it what average to compute. Average of their sex, average of their age, average of their income. We want to say income. And you'll notice there's a little hint here again. Item, the embedded object. So let me tell you, this is a little bit of a trick, but once you know it, what that's telling you is that each person in the population will be named item in turn. It's going to go through each person in the population in turn. This is one of Jeff's favorite sort of moments. So it's going to go person 0, and it's going to have person 0, and that person's going to be named what? Item. It's going to name that item, and it's going to determine the value to use for them. And then it's going to go to person 1, and it's going to call them item, and it's going to use the value for them. And it's going to go to person 2, and they're going to be called item, and it's going to use the value for them. For each person, it's going to be taking their what? Their average. Okay, good. So we want to say what to compute for each person called item. We want to compute what? Their what? Of their income. So we're going to say item dot income. This dot here is like it's like an apostrophe s. It's like the item's income. The income of item. Item dot income. It's the income that is associated with item. That's the characteristic of item. That's given by item. Okay. Item dot income. Are people okay with that? Item's income. Make sense? Okay. Okay. Great. Okay, great. So that's all we need. That's for average income of the whole population. Now suppose we want to, well, should we run that? Let's oh, sorry? Yes, but we can actually leave that blank. Let's do it for the whole population right now. Ante's 2 steps ahead of us, but as he will normally be. But let's just run it now, get the notion of a statistic. Can we run it? And guess where we see the statistic? By clicking the population. And you'll notice it says that the average income is fairly favorable. Okay? Okay, so now should we go do it male income and female income? Okay, this is just about as easy. Okay, so where do we go to define a statistic, ladies and gentlemen? Do we go to experiment? Do we go to person? We go to main, and where in main? Population, yeah. Okay, and where do we go to add a statistic? We go to the statistics area and we press add. We're going to do average male income now. Average, well, let's say average female income, okay? And this is going to be an average over what expression? What are we going to be taking the average of? Item.income. It's the exact same thing as earlier. But now we have a condition. This is what Ante was seeing far ahead. Oh, that was Joachim. Oh, okay, I thought it was Ante. Sorry. Ante is right in front of Joachim in my viewpoint, so it was almost a ventriloquist. Okay, so the condition here is going to be that the person is female. So how would we say, is the person female? It's going to be true if the person is female, otherwise false. How do we test that in Java? Sex, and do we say sex equals female? Equals. Man, you folks are good. Okay, great. And finally, the peak of the crescendo, we're going to add one final statistic that you're going to tell me exactly what to type. I'm not going to tell you at all. Okay, so here's average male income. You're going to tell me how to do it. The music is rising. What am I going to type for, what am I going to enter for the type? Average, good. Wow, okay, we're cooking with gas. Well, how about for the expression? Item.income, beautiful. How about the condition? Okay, sex equals, is it single equal or double? Equal, because we're just testing it. This is going to be true if and only if they're male, so what do I put here? Male. Yep, good. Okay, so ladies and gentlemen, oh, look at that. Sex cannot be resolved. Okay. Oh, thank you. Thank you. Man. Sorry, I was toned out. Should have caught that. Item.sex. Yeah. So let me go put that up on the big screen. Sorry, folks. I lapsed on that. Item.sex equals female, item.sex equals male. Why? Because each person is called, in turn, what? Item. So each person is being evaluated. We're calling them item in turn. We're then taking to see if they are female, and if so, we are computing their income with item.income and accumulating it and taking the average. Does that make sense? Does that make sense? Okay, who needs help? Okay, who's beyond help? Okay, someone in the back. Annie, could you help the person back there? Help them catch up. Yeah. Okay, great. Terrific. Okay, so should we run this thing? Should we run it? Great, let's run it. And where would we go to see the statistics? Statistics are associated with population. Let's go click on the population. Okay, so here we have an average income in this virtual world of just over it's about $5.1 million a year. And the average female income is just below $1 million, and the average male income is $8.7 million. Is there a disparity here? Yes. Unfortunately, true for many areas of the world.
So this is not an academic population.
This is not an academic population. Although there's problems in academia too, that's for sure. But no, the salaries are marketed as being well outside the academic range. Okay, so that's all. Any questions regarding this? So we've just seen an exercise of introducing heterogeneity into agent populations, having their visual appearance be set by the characteristics, having each person associated with certain of these characteristics. We had characteristics of the population that are continuous, such as income and age, populations or characteristics that are discrete, such as sex. We had conditional distributions, which can, combined with a marginal distribution, can yield something that's just as powerful, specifying a joint distribution. And I want to highlight one point, though, and this is a point that you may have felt is there, but maybe it wasn't quite expressed. Any logic is very different than a lot of traditional platforms in the sense that you're specifying a model in many of its aspects, not all regrettably, but in many of its aspects, the model is declarative. What do I mean by that is you specify more what is in the model and less about how exactly it's computed. So you can simply specify, mark my words, you can specify, for example, for a person's appearance, let their radius be 2 times the log of 1 plus their income. You could specify, let their color be determined by this value. You can specify, let their sex be determined by this formula. Let their income be determined by this other formula. And it's taking care behind the scenes to kind of arrange for these things. Now, there's no magic here in the sense that there's very particular things going on, but you don't have to know about them unless you need to, unless you want to know about them. And like in Excel, where you can specify formulas, how this cell depends on these other cells, here, not all, but much of the work is specified by putting down sort of a declaration of what you want to see to be the case, and it will take care of how that is. And we will see that soon enough with state charts and describing their evolution over time, that much of that is declarative as well. So, with that in hand, I'm glad to take further question, and we will break for a much needed bit of refreshment.
I just wanted to know, so is, in terms of running your simulation, that nested if statement you had, and a function call, is there a speed difference?
The speed difference is immaterial in the scheme of things. The rest, it's in the noise of the model. Essentially, it's unnoticeable. And where there is a big speed difference is by sparing the time and debugging the model. So if you have code that's more complex, often you have more mistakes and it takes more time to debug it, and it's harder to understand it. So you're wasting a lot of time that could be put into speeding up aspects of the model. Could be put into things which will really make a difference, such as making events go off less frequently, or judiciously choosing how much detail you need to incorporate and not incorporating more than that, or putting in place mechanisms that will minimize the burden associated with visualization. And it's really those bigger things and better algorithms that make your model run much faster. The difference between a function call or putting it inline, there is, the truth is there is a tiny bit of a difference, but it's virtually unnoticeable compared to all the other mechanisms that are needed. It would be like a spark of light in a operating theater that's illuminated by giant halogen lights. It's almost unnoticeable. Yeah, all right. Yeah.
I think that on your microphone's actually quite good.